Here we have a rectangle, 9 by 27. Obviously, this rectangle is not drawn to scale here. Inside of this rectangle, there's another rectangle, small rectangle, that has an area of 13. We have two triangles here, one with an area of 26 and another with an area of 4. And we asked to find area of the other two triangles, which we call area A and area B. Now, that would be fine if this problem stops here, but the author of this problem decided to make things more complicated and said that those areas A and B have to be integer. All right, let's see how we can handle this problem. We're going to call horizontal length of this rectangle as A, vertical length is going to be B. Also, we're going to call the distance from the top of the small rectangle to the top of the large rectangle X, and the distance from the right side of the small rectangle to the right side of the large rectangle, we're going to call it Y. Now, we can use those letters, those unknowns, to describe all the areas we have here. First of all, let's start with the area A. This is a triangle. Area of a triangle is base times height divided by 2. So in this case, the base is A, the height is X, and we're dividing it by 2. B is also base times height times half. So base is B, height is Y, and there's a half. Now the area of the small rectangle is A times B, and we know it's 13. The area of this triangle on the left is base times height divided by 2. So the base will be B, the height will be this distance, and this distance is 9 minus A and minus Y. And the area of this triangle at the bottom here is the base, which is A times height, which is 27 minus X and minus B, and divided by 2. Now what we need to do, we need to play with these two formulas a little bit. First of all, let's multiply them by 2 and open the parentheses in the formula on the left. Now we see that we have A and B here. A and B is 13. Let's plug it in and let's simplify this. We're going to get the formula like this. So we're going to do the same thing with this formula. Now let's just modify these two formulas a little bit. And now we're going to look at the formula here. We have B here, but we know that B could be expressed via A using this formula. Let's do that. And the next thing we're going to do, we're going to express A from here and substitute this value over here. This is what we're going to get. Next thing, we're going to get rid of denominator by multiplying denominator to both sides of this equation. And this is the formula we're going to get. We can actually simplify it a little bit. And now let's look what we have on the left. On the left, we have two parentheses, two factors. And since both A and B are positive integers, in this case, both of these parentheses have to be integer. And their product equals to 3 to the 5th power times 13. And what it means, by using the fundamental theorem of arithmetics, is each one can be represented as 3 to some power k times 13 to some power l. In a similar way, the other one is 3 to the power of m times 13 to the power of n. But obviously, since when we multiply these two things, we should get 3 to the 5th times 13. It puts restrictions on the power. In particular, k plus m should be 5, and n plus n should be 1. And obviously, they cannot be less than 0. Now, if you look here, it means that the left-hand side is greater than 65, and therefore the right-hand side also should be greater than 65. In a similar way, if you look at this formula, we find that left and right-hand side have to be bigger than 21. Now let's look what's happening here. First of all, the question is, can k or m be 0? And the answer is no. And the reason for that is because if k, for example, equals to 0, the L could be either 0 or 1, which means that the left-hand side here could be 1 or 13. And there's no way for us to get the number greater than 65. In a similar way, we can show here that m has to be at least 1. And since k and m both at least 1, it means that none of them could be 5. Because together they have to give us 5. We know that L could be either 0 or 1. Let's consider those two cases separately. First, let's start with L equals to 0. If you look at this inequality, you'll find that if L equals to 0, in order for 3 to the k to be greater than 65, k should be greater or equal than 4. But here we have a restriction that k is less than or equal than 4, which means that the only option for k is 4. Now if k equals to 4, L equals to 0, look at this formula, we get that 65 plus 2b should be 81. And from here we find that b equals to 8. The last thing we want to do here is to calculate b here, and b will be 9. And the reason why I want to do it just to make sure, to be certain, that b is less than this 27, because it can't exceed that. We know L and k, so because of these formulas, we automatically can get m and n. They both should be 1. And now we substitute those values here, and we're going to get the expression like this. From here we find that a should be 9. And as in case of b, we also want to find this distance small a using this formula. The distance equals to this, and we're doing this to make sure that a is less than 9, and it is. So as far as we see, when L is equals to 0, there's one solution where a is equals to 9 and b equals to 8. When L equals to 1, if you want to satisfy this inequality and this inequality, you'll find that k should be between 2 and 4. Since L equals to 1, n has to be equal to 0. And when n equals to 0, in order for us to satisfy this condition, and this condition, m could be only 3 or 4. Okay? But now let's consider both of those cases. What happens when m equals to 3? Well, when m equals to 3, if I'm looking here, k has to be 2. If I look here, yeah, that's possible. But the other possibility over here is m equals to 4. But when m equals to 4, k equals to 1, and we see that is not possible. Therefore, m can only be 3, but that means that k has to be 2. Now we found L, m, and k. So if we substitute them right here, we get this, and that gives us b of 26, and a small b of 13. We're still good. We're still less than 27. In a similar way from this guy, we get equation like this that let us find a, which is 3, and we check that a in this case will be 1. So what we found here, that this problem has two solutions, 9 and 8 here, or 3 and 26.